All right, let's talk about a project in Germany, right in the heart of Europe. It was called Silicon Junction, and it was supposed to be the continent's crown jewel in the global tech race. I mean, the plan was absolutely monumental. Build one of the most advanced semiconductor factories in the entire world. But this $30 billion dream, yeah, it turned into an industrial nightmare, and fast.
$30 billion. Just let that number sink in for a second. That was the staggering price tag for this vision in a place called Magdeburg. And that money, it just vanished before a single shovel even hit the ground. All that's left is an empty field and a whole lot of questions.
So you have to ask, right? How on earth does Europe's biggest, most important tech project just collapse? Well, the answer pulls back the curtain on the incredibly high-stakes game of global technology, big money, and even bigger ambition.
Okay, so to really get to the bottom of this, our investigation doesn't start in Germany. No, we have to look across the Atlantic. Because the first fatal blow, the thing that started this whole mess, came from a massive financial crisis brewing inside the project's parent company, Intel. And that's the key thing here. This wasn't a story of German bureaucracy or European red tape getting in the way. Not at all. The wound that killed this project was totally self-inflicted. It was a perfect storm hitting Intel's main business, right there in the United States.
And when I say financial storm, I mean a hurricane. Just look at this number, a nearly $3 billion loss in a single quarter, in just 3 months. This wasn't just a bad quarter, you know? This was a 5-alarm fire, a sign of a company in a deep, deep crisis, just bleeding market share as the PC market slowed to a crawl.
And here is the absolute kicker. Even with a massive, nearly $10 billion subsidy from the German government, Intel still had to come up with $20 billion of its own cash. Now think about it. For a company that's already losing billions, finding an extra $20 billion, it just wasn't going to happen. It became an absolute impossibility.
You know, there's this internal company quote that just says it all. A pulling of the ripcord to save the parent entity. That's what this was. The German project wasn't a strategic investment anymore. It had become a giant anchor dragging the whole company down. So they cut the rope. Canceling it was an act of pure survival.
But, you see, the money problems were only half the story. The other reason this whole thing imploded was because the project itself was built on this incredibly risky technology gamble. A gamble that just didn't pay off. So the entire factory in Magdeburg was based on what's called the foundry model. Now, for its whole history, Intel made its own chips for its own products. But this new plan was totally different. The idea was to manufacture chips for other companies. We're talking giants like Apple or Nvidia. It was a brand new, completely unproven business model for Intel. And the fate of a $30 billion factory was riding on them getting it right.
And just to pile on the risk, the factory wasn't just using any old tech. It was designed to produce chips using brand new, bleeding-edge technology. These are called the 14A and 18A process nodes. But here's the problem. By late 2025, it became painfully obvious that the big customers, the Apples and Nvidias of the world, they weren't signing up. They were really skeptical that Intel could even deliver on this new, unproven tech.
You can literally watch the whole thing unravel like a line of dominoes. First, they bet the farm on this unproven technology. That's domino 1. Then, they couldn't get the key customers on board. Domino 2. Then came the big one, a stunning admission from Intel that they might have to abandon the technology altogether. And once that domino fell, the whole project was basically obsolete, technologically redundant before a single brick was ever laid. So, okay, the project is dead. The money's gone. What's left behind? Well, the collapse sent these huge shockwaves through the local German region, and it forced Europe to completely rethink its entire strategy for competing in the tech world. Now, while the official announcement in 2025 came as a shock to the public, the truth is people inside the industry saw the writing on the wall 2 years earlier. When Intel announced a so-called pause back in 2023, everyone in the know understood what that really meant. It was a soft cancellation. It was a way to manage the political fallout while the company quietly planned its escape route. And for the local region, the devastation was just immense. I mean, the promise was 3,000 high-tech jobs that could have totally reversed the brain drain the area was suffering from. But the reality? Those jobs just evaporated. The state was left with a massive hole in its budget. And that dream of a thriving Silicon Junction, it's now just a 400-hectare empty field. And this is so important to understand. The damage wasn't just about the money. It was psychological.
This was a really painful lesson for Europe about the huge, huge risk of betting billions of taxpayer dollars on one single foreign company, a company whose priorities can just change overnight for reasons that are completely out of your control.
But you know what? Out of the ashes of this failure, a new and maybe much wiser strategy is starting to take shape. Europe is learning from this massive mistake, and it's fundamentally changing how it invests in its technological future. This whole fiasco forced a massive shift in thinking. Europe is moving away from what you could call whale hunting, trying to spend billions to land one giant high-risk foreign company. Instead, they're turning to ecosystem gardening. And the idea here is totally different. It's about nurturing a whole diverse portfolio of smaller, homegrown European projects. The goal isn't one giant win. It's about building something that's resilient and can grow in a more diversified way. And the good news is that subsidy money isn't just gone. Those billions that were promised to Intel, they're now being put back to work. They're being rechanneled to support this new gardening strategy, funding a whole range of European projects, from things like quantum sensors to other chip manufacturing ideas. Trying to build a massive semiconductor factory, a fab, is one of the toughest things you can do in the industrial world. Seriously. We've seen these huge, ambitious plans just fizzle out, with billions of dollars vanishing into thin air. But something really different is happening in Dresden, Germany. There's a project called ESMC, and it's not just staying on track, it's thriving, where so many others have failed. So let's pull back the curtain and look at the blueprint for what could be the future of high-tech manufacturing in Europe. So here's how we're going to break it all down. First, we'll look at two totally different ways of thinking about building these mega factories. Then we'll get into the real secret sauce, its ownership. After that, we'll check out their brilliant tech strategy and then see how they're solving the massive talent shortage before it can even start. And finally, we'll ask the big question, is this the new playbook for all of European industry? All right, so let's dive in. The big challenge is pretty clear, right? Europe desperately wants to build up its own chip supply chain, but man, it is incredibly hard to do. And this has led to two completely different strategies playing out right now with, dramatically different outcomes. On the one hand, you've got what I like to call the field of dreams approach. Like the movie. Build a giant, super advanced factory and just hope that the customers eventually show up. It's a massive, massive gamble. But then you have Dresden's cluster model, and the philosophy here couldn't be more different. It's build the factory to serve the huge, guaranteed demand that is literally right there on your doorstep. One's a bet, the other is a sure thing. And that brings us right to the first and maybe the most important pillar of Dresden's success. It's an absolute masterclass in business strategy, and it all boils down to one simple question. Who actually owns this factory? Okay, so take a look at this. The ownership structure here is the absolute key to everything. This isn't just another TSMC factory. Yeah, of course, the world's #1 chip maker has the majority stake at 70%. But look at the other partners, Bosch, Infineon, and NXP. These aren't just random investors. These are the titans of European industry. We're talking about the backbone of the automotive and industrial sectors right here. And here is the absolute genius of the plan. The partners who own 30% of this factory, they're also its biggest customers. They have contractually guaranteed that they will buy the chips that this factory makes. What does that mean? It means they have completely eliminated the market risk from day one. They aren't hoping for customers to show up. The customers are co-owners, building the exact supply chain they know they're going to need. It's incredible. Okay, so the second reason this is working so well is just as smart and just as practical. It's about the kind of chips they've decided to make. They're not chasing flashy headlines, they are chasing real sustainable demand. All right, a super quick tech primer so we're all on the same page. When people talk about chips, you'll hear them talk about process nodes, measured in nanometers, or nm. All you really need to know is that a smaller number usually means a more powerful, more cutting-edge chip, which also means it's way more expensive and much, much riskier to produce. Now, check out the choice ESMC made. They are purposefully not making those super tiny, sub-7 nanometer chips that go into the latest iPhones or AI servers. That is a high-risk game that costs an astronomical amount of money. Instead, they are focusing on what's called 28 down to 12 nanometer nodes. This is the reliable, proven, cost-effective workhorse technology that is the absolute sweet spot for Europe's core industries, automotive and industrial manufacturing. And what does this workhorse tech actually make? Well, it makes all the essential stuff. We're talking about the microcontrollers, the sensors, the power management chips, all the little brains that keep the assembly lines at a company like Mercedes humming and keep Siemens factory automation systems running smoothly. It's a perfect marriage between what the factory can make in what the European economy actually needs.
And don't let that workhorse name fool you into thinking this is some small-time operation. This place is going to be a beast. We're talking about churning out 40,000 silicon wafers every single month. That is a huge amount of production that is going to make a real dent in securing Europe's supply chain and making it less dependent on imports.
Okay, so you've got guaranteed customers, you've got the perfect technology. But, a bunch of concrete and silicon is pretty useless without the brilliant people you need to actually run the machines. And this is ESMC's third pillar, a preemptive strike on the global talent shortage.
They've got a name for it, the Semiconductor Talent Incubation Program, or STIP for short. And it's just an incredible way to build a world-class workforce from scratch, designed to fit the factory's needs like a glove.
So here's how this journey works. First, they handpick top students from German universities. Then they fly them all the way to Taiwan for some serious academic training. After that comes the really priceless part, hands-on, practical experience at TSMC's own state-of-the-art facilities. Then they come back to Germany, not as rookies, but as a ready-made team of expert engineers who are already soaked in TSMC's world-class culture and standards. And listen, this isn't just some vague idea for the future. It's already in motion. The program kicked off in 2024, it's expanding across all of Germany in late 2025, and it's timed perfectly to deliver the skilled workforce right as the factory doors swing open in 2027. It's just a brilliant way to solve that problem of finding talent.
So you've got a killer business model, a super smart technology strategy, and an innovative plan for your workforce. The only thing left to do is actually build the thing, to turn that vision into concrete and steel reality.
And this timeline right here is the ultimate proof that the Dresden model flat out works. They broke ground in August of 2024. By the end of 2025, the steel skeletons of the buildings were already rising from the ground. The schedule is locked in, the super sensitive equipment starts getting moved in during the second half of 2026, and full-scale production kicks off in late 2027. This is what TSMC is famous for: flawless execution right on schedule.
All right, today we are diving into the story of a massive, high-stakes European tech project. I mean, this thing was supposed to be the absolute crown jewel of France's big comeback in semiconductors. But this multi-billion-euro dream, well, it ran headfirst into a very, very solid wall. So the vision here was huge. It was all happening in a place they call the Silicon Valley of the French Alps. And look, this wasn't just about building another factory. No. This was a strategic power play, a true mega fab that was meant to secure Europe's technological independence in the global chip race. But fast forward a few years, and that incredible vision was completely put on ice. The project gets suspended, and all those billions in funding, they're totally frozen. I mean, technically approved, sure, but legally untouchable. The whole dream just morphed into this incredibly complex, industrial, and frankly, legal nightmare. So how on earth did this happen? How does a project with this much momentum, this much government backing, just stop in its tracks? Okay, let's dive in and unpack this whole thing.
First things first, we have to talk about the sheer scale of the money involved. We're looking at 2.9 billion euros. That's billion with a B. All of it public state aid from France and fully signed off on by the European Commission. The stakes really couldn't have been higher, and you need to remember that number because it is absolutely central to this entire story.
So this project was basically a marriage of two absolute giants. On one side, you had STMicroelectronics, right? Europe's homegrown chip champion, and they were desperate for more capacity. And on the other side, you have GlobalFoundries, an American specialist that saw a golden ticket to get into Europe's really lucrative automotive market.
And the technological glue holding this whole thing together was something called FD-SOI. Now, this is a pretty unique chip technology that was actually pioneered right there in France. It just strikes this perfect balance between performance and power efficiency. So, think of it as the perfect tech for stuff like automotive radar, 5G antennas, and all kinds of other connected gadgets. It was really the special sauce that made this partnership work.
And you can totally see why this partnership made so much sense on paper. ST, they really needed to expand, but they couldn't afford the crazy cost of a new factory all by themselves. And GlobalFoundries, well, they had the exact manufacturing know-how, and they wanted a key to that European market. It seriously looked like a perfect, symbiotic match where absolutely everyone was going to win.
And the goal they set was just massive. The plan was to be churning out 620,000 wafers every single year by 2028. I mean, that number alone tells you everything you need to know about the ambition here. This wasn't just another factory. It was designed to be a true mega fab that could compete with anyone on the world stage.
But then, things started to unravel, and it happened really, really fast. The whole thing was announced with a ton of fanfare in July 2022, but just 3 years later, by the middle of 2025, the project had slammed into a wall. And by November, the entire collaboration was, for all intents and purposes, dead. So what happened in that really short window?
Well, here's the thing. There wasn't some single bad guy in this story. The project was really just a victim of terrible timing. A global economic downturn hit the chip market, and it hit it hard. And all of a sudden, GlobalFoundries is facing intense pressure from its shareholders, and at the same time, its other factories weren't even running at full capacity. So pouring billions into a super expensive new fab in France, it just didn't make any financial sense anymore. So the money was pulled back to protect their core business.
And this right here, this is the public statement that pretty much signaled the end. The company said that any future expansion would, quote, align with customer demand. Now that is just classic corporate speak for, we are hitting the brakes and we're hitting them hard. This was the exact moment that the dream officially split from reality.
Okay, so this brings us to what is easily the most frustrating part of this whole saga. And it's the question you're probably asking right now. If GlobalFoundries is out of the picture, why couldn't STMicroelectronics just take that massive 2.9 billion euro subsidy and finish the project by themselves?
Well, the answer is a mind-numbing bureaucratic trap. You see, that 2.9 billion euro aid package wasn't just for a factory. It was legally tied to that specific joint venture between those two companies. The second GlobalFoundries walked away, the entire legal foundation for that funding just evaporated. France couldn't just hand the money over to ST to go it alone. No, that would mean starting a brand new, super long approval process with the EU and Brussels. The money was right there, but it was tangled in red tape, basically locked away in a legal vault.
And this wasn't just some abstract problem on a balance sheet. No, this had major real-world consequences. That capital freeze meant all the economic benefits the region was counting on. We're talking local infrastructure, housing for thousands of new workers, new transport links, all of it was just left hanging. The entire local economy that had been gearing up for this huge boom was suddenly put on indefinite hold.
So, what happens now? Well, STMicroelectronics hasn't just walked away from the site. Instead, they've pivoted. The original grand dream of a global megafab is gone, and in its place is Plan B. A much smaller, more specialized facility that's focused on serving ST's own internal needs.
This new reality is, a lot more modest. ST is still building out the facility, just much more slowly, and for a totally different purpose. Now it's all about their own products, things like microcontrollers and edge AI chips. But here's the most important part. This new plan means ST is finally in control of its own destiny. They're no longer tied to the changing whims of an outside partner.
All right, let's jump right in. Picture this. We're in Sicily on a brownfield site, literally in the shadow of Mount Etna. It's a pretty dramatic setting, right? Well, it's here that Europe is building a global stronghold for a technology that is quietly but completely changing the world around us, starting with the car in your driveway. It's a great question, isn't it? And you've probably noticed it yourself. The performance of electric vehicles, it seems to have taken this massive leap forward all of a sudden. But it's not just about jamming in bigger batteries. No, the real secret is hiding in the tiny, powerful electronics that control the flow of all that energy. And the answer, the key to all this, is a really remarkable material called silicon carbide, or SiC for short. Now, this isn't just some small incremental improvement. We're talking about the fundamental physics enabler of the modern EV. It is literally what allows electric cars to be more efficient, to charge way quicker, and to go so much further on a single charge. So what gives silicon carbide these superpowers? Well, it all comes down to one key principle. It's what's known as a wide band gap semiconductor. Now, without getting too lost in the physics here, that wider band gap, it's about 3 times wider than regular silicone. It just means it can handle much, much more extreme conditions. Think higher voltages, way higher temperatures, and incredibly fast switching, all while losing less energy as heat. It's a total game changer. And when you put them side by side, the advantages become crystal clear. Right where standard silicon just hits a wall, silicon carbide is just getting started. It lets engineers push EV systems to 800 volts and even higher. It can run hotter without breaking a sweat, switch power on and off in the blink of an eye, and it's just so much more efficient. For an EV, what does that mean? Well, more power to the wheels and way less precious energy wasted.
Okay, so if this stuff is so amazing, why isn't it everywhere? Well, there's a catch, and it is a big one.
The thing is, silicon carbide is just notoriously difficult to manufacture.
And when I say difficult, I mean the process is just incredibly demanding. First, you need furnaces that are burning hotter than 2,500 degrees Celsius. I mean, that's almost half the temperature of the surface of the sun. Then, you have the slow energy-guzzling process called sublimation. The whole thing is super prone to these tiny invisible defects that can ruin an entire batch. And even if you get all that right, you still have to slice the second hardest material on Earth. It's a massive, massive technological headache.
And this is where our story brings us back to Sicily. The company STMicroelectronics, they recognized that the main bottleneck was just getting the raw materials. So they decided on a pretty radical strategy with their new site, which they call Katana. And the core of their entire strategy can be summed up in this one phrase. Instead of depending on a really fragile chain of suppliers scattered all over the globe, they chose the resilience of total vertical integration. In other words, they decided they were going to do it all themselves, right there, under one roof.
So how does this actually solve the problem? Well, the Katana campus was designed from the ground up to house every single step. They start by making the raw substrate wafer themselves. Then they grow that critical active layer. After that, they fabricate the actual device on that wafer, and finally, they package the whole thing up into a finished module. It's about having complete control from start to finish.
Now, this isn't just about control, it's an absolutely brilliant business and engineering move. It solves two huge problems. First, it gets rid of what's called margin stacking. You know, that's when every supplier in a long chain adds their own profit, which just drives up the final cost. Second, and this is maybe even more important, it creates this super tight feedback loop. The scientists growing the crystals can literally walk down the hall and talk to the engineers making the chips. That lets them solve problems and improve the number of usable chips, the yield, incredibly quickly.
Of course, having an ambitious plan is one thing, but actually pulling it off, that's a whole different story. So what were the key ingredients that made this all-in-one factory such a success? Well, a big part of the answer is a very, very large number. The project was backed by a massive 730 million euro investment from the Italian state. That kind of support was absolutely critical to getting this high-risk, high-reward strategy off the ground. But, it wasn't just about the money. It was about how that money was used. See, the Italian government's support was fast and it was laser-focused. Instead of getting bogged down in some complex multi-company group, the aid was aimed right at a single national champion, ST, to solve one very specific problem, mastering the production of the substrate. And on top of all that, they had a huge home field advantage. The factory was built in what's known as the Etna Valley, which was already a tech hub. This meant they had deep ties to the local university and research councils, and, this is crucial, a ready-made workforce of specialized engineers. That helped them completely avoid the talent shortages that often doom these kinds of huge projects. So you've got all the pieces in place, the right strategy, the funding, the local talent. What's the result? Well, it's been nothing short of transformative. It has basically created a brand new center of gravity for European technology. A huge part of their success is that they're leading the charge to bigger 200mm wafers. Think of it like this. That bigger wafer gives you almost twice the surface area to work with. It's like getting almost double the number of cookies from a single sheet of dough. It just makes the whole process way more economical. And this really brings us to their core strategic goal. The Katana facility is ramping up to supply 40% of ST's own internal need for these critical substrates. See, this isn't about trying to dominate the open market. It's about securing their own supply chain. It's about building a fortress of resilience in a world that feels more geopolitically uncertain every day. And they are moving fast. Commercial production is slated to begin in late 2025, and by early 2026, the project is already going to be ramping up and hitting its key milestones. This timeline just shows you how quickly this huge vision is becoming a reality. The result of all this is powerful, and it's really clear. This single site, through this amazing combination of bold strategy and smart execution, has effectively become the silicon carbide capital of Europe. That is a huge strategic win, not just for the company, but for the entire continent. And you know what makes this success story so durable? Its future isn't tied to the crazy ups and downs of the consumer electronics market. No, the long-term demand for this technology is locked in by the irreversible trend of the energy transition. The world needs this stuff to electrify transportation and industry, which makes Katana an absolutely critical piece of infrastructure for decades to come.
So today we're going to unpack a story that, honestly, it reads like a high-tech thriller. It's about this massive €3 billion project that was supposed to be a crown jewel for Europe, but instead, it just vanished, almost as fast as it appeared. We're going to dig into what is, you could argue, the single biggest failure of the European Chips Act era. And trust me, it's a story that serves as a huge warning for Europe's tech ambitions. And just look at this timeline. I mean, it tells you pretty much everything you need to know about how fast this whole dream died. In 2023, you've got these huge headlines, world's largest silicon carbide chip factory coming to Germany. And then, less than 2 years later, poof, it's gone. The big question is obvious. What on earth happened in that tiny window to make a project this big just completely collapse?
And make no mistake, this was a massive, massive dream. We're talking about €3 billion. Just let that number sink in. That single number tells you everything about the scale of the ambition, all the economic hopes that were pinned to it, and well, ultimately the size of the failure we're about to get into. You know, the vision here was truly something else. The plan was to take this old, retired coal power plant in a region trying to move on from its industrial past and turn it into a shiny, state-of-the-art semiconductor powerhouse. But instead of becoming this great symbol of renewal, it became a cautionary tale about just how fragile these industrial dreams can really be.
So, what went wrong? Well, it wasn't just one thing. This project was doomed by what you can only call a perfect storm. This wasn't one company hitting a rough patch. It was a total convergence of two separate massive crises hitting both partners at the exact same time. It was a joint venture that just got hit with the double whammy.
All right, so let's meet the two partners in this venture. On one side, you've got Wolfspeed. They're the American leader in silicon carbide tech, the majority partner, and this German factory was supposed to be their big move into Europe. Then, on the other side, you have ZF Friedrichshafen, a giant German auto parts supplier. They were the minority partner, and for them, this was all about locking down a stable supply of chips for their EV parts. On paper, it looks like a perfect match, right?
Well, let's pop the hood on Wolfspeed for a second. See, unlike some of their competitors, Wolfspeed was what you call a pure-play silicon carbide company. They were all in on this one technology. That meant they were spending a ton of money, that's the high capital expenditure, and they had negative free cash flow. In simple terms, they were burning through cash way faster than they were making it. On top of that, they were having major headaches getting their big new factory in New York up to speed, plus the whole global EV market started to slow down, and suddenly that financial foundation starts to look really, really shaky.
And that financial pressure cooker, it eventually just exploded. By 2025, Wolfspeed's stock had tanked, the company was facing a massive cash crunch, and it had to file for Chapter 11 bankruptcy. Now that is a huge traumatic step for any company. It's when survival becomes the one and only goal.
And this right here, this is the first fatal blow. Wolfspeed did manage to come out of bankruptcy, but it was a totally different company. The new game plan was all about ruthless efficiency. And when you need to save every single penny, what's the first thing you cut? Yep, a speculative, super high-risk, multi-billion-euro project on another continent. Suddenly, the German factory wasn't a strategic move anymore. It was a luxury they just couldn't afford.
But remember what I said, this was a perfect storm. So just as Wolfspeed is fighting for its life back in the US, its German partner ZF is getting swept up in its own totally separate crisis. The problem wasn't just on one side of the Atlantic.
This number pretty much tells the whole story of ZF's crisis. 14,000. That's how many jobs ZF announced it might have to cut just in Germany. Why? Well, the super fast shift to electric vehicles meant their old-school traditional drivetrain business was shrinking fast. They were facing a serious downturn, forcing them into this really painful period of austerity.
So just put yourself in their shoes for a second. Your company is talking about huge layoffs, you're fighting to stay competitive. In that kind of environment, is it even possible, politically or financially, to keep pouring money into a risky factory with a partner that just went through bankruptcy? The answer is absolutely not. So ZF pulled its support, and that was the second and final blow.
So the collapse of both partners is a heck of a story, but it wasn't the only fatal flaw here. Even if both companies had been perfectly healthy, this project was kind of built on shaky ground from the start. The challenges tied to building in Germany itself might have doomed it anyway.
The key term you need to know here is greenfield. See, this wasn't about just expanding a factory they already had. This was about building everything. The clean rooms, the water treatment, the power stations, everything from absolute scratch on an empty piece of land. And that just adds a massive amount of risk, because all the money, all that capital, is spent up front, before you've even made a single chip.
But even beyond the risk of building it, there was an even bigger, more fundamental problem that was never really solved: the cost of electricity. Making silicon carbide chips is an incredibly energy-intensive process. We're talking super high temperatures to grow these crystals, which means it is an absolute power hog.
And this chart just lays it all out, doesn't it? Germany's industrial energy prices are just way, way higher than in the United States. It's not even close. Even with some government help, the long-term cost of just keeping the lights on in a factory like this in Germany was a huge competitive disadvantage compared to running it in the US. And that brings us to the American advantage. Back home, Wolfspeed could get not just cheaper energy, but also these powerful government incentives, like the Inflation Reduction Act, which hands out tax credits that make operating a factory way more profitable. Look, when every dollar counts, you build where the math makes sense. And for Wolfspeed, all the math was pointing right back to America.
So a €3 billion factory just disappears. What does a failure this spectacular really mean for Europe's bigger goal of becoming a leader in the global chip race? What are the big takeaways from this whole cautionary tale?
Okay, here are the crucial lessons. First off, government money can't save a project if the companies behind it are on shaky financial ground. It just can't. Second, building from scratch, these greenfield projects is incredibly risky and you need really deep pockets. Third, for power-hungry industries like chipmaking, competitive energy prices are not a nice-to-have, they are an absolute deal-breaker. And finally, local investment decisions are now in a global fight, directly shaped by policies like the US Inflation Reduction Act.
All right, today we're diving into a story that's way more than just a win for some tech company. It's really about a massive choice that's facing all of Europe. We're going to look at two very different ways to build the future. One that failed, spectacularly, and another that's already changing the game.
Okay, so let's get right into it. Imagine you want to build a huge, state-of-the-art factory. You've basically got two paths. There's what you could call the hard way, starting from absolutely nothing on an empty plot of land. That means years, literally years, of dealing with permits, all sorts of red tape, and just a ton of risk. But then, there's the smart way. You find a place that's already got the bones of a factory, and you build on top of that. It's a massive head start. And that choice, that's exactly what this story is all about. You've got Europe in this big race to make more of its own computer chips. We saw this one really hyped up project over in Germany just fall apart. But at the same time, in this little town in the Czech Republic, a totally different way of doing things led to this huge success. And the crazy part is, the difference wasn't about money or big dreams. It all came down to strategy. So that brings us to the secret sauce, the strategy that changed everything. It's called the brownfield approach. And it's pretty simple, really. You're not looking for a green field to build on. No, you're looking for an existing industrial site that you can reuse, upgrade, and expand. It's about being clever with what's already there.
But why is that such a game changer? What's the big deal? Well, you have to understand, in the world of making chips, speed is everything. There's this one metric that matters more than almost anything else: time to yield. And that's just a fancy way of saying, how fast can you get this factory up and running and actually making chips that work?
And this is where the benefits just stack up. They're super practical. Think about it. By picking a spot that already existed, the onsemi project in Rajnov just skipped years of potential headaches. The land was there, the permits, mostly done. The pipes and wires for utilities, already connected. This wasn't just a slight advantage, you guys. This was a massive head start in a race where every second counts. But hold on, it gets even better. This story isn't just about a clever real estate move. The town itself, Rojnov, had this kind of secret weapon, a unique advantage that was just perfect for what they needed to do. And this is where we get to the people, the human side of all this. See, Rojnov wasn't just some random town with an old factory. For decades, it was the heart of silicon production for all of Czechoslovakia. So what does that mean? It means onsemi could hire people whose parents, maybe even their grandparents, worked in this exact field. They had generations of expertise in the super complex art of growing silicon crystals. And that's a skill you just can't learn from a textbook. It's deep, hands-on knowledge.
So when onsemi saw this perfect combination of the right place and the right people, they knew they'd hit the jackpot. And they went all in. We're talking a massive investment, 1.64 billion euros, to turn this place into an absolute world-class powerhouse.
And an investment that big, it doesn't just stay inside the factory. It creates huge ripples. This one project is set to create 3,000 high-value skilled jobs. That's a huge deal, and it's going to completely transform the economy for that whole area.
Okay, let's step inside for a minute, because what they're actually building here, it's not just another chip factory. The way it's designed is what makes it so incredibly important for all of Europe.
What we're looking at is a truly end-to-end operation. You see, most plants, they just get the pre-made silicon wafers delivered and then they work on them. But not here. Here, they're going to do the whole thing under one roof. They'll grow the raw silicon carbide crystals themselves, slice them into wafers, do this really complex step called epitaxy, and then build the final chip. The whole shebang. So why does that matter? Well, it all comes down to one word: control. When you control the whole process from start to finish, you keep the value of the most expensive part, that raw material. But even more important, you protect yourself from all the crazy supply chain problems we've seen around the world. And this isn't just some business school talk. This means a more stable supply of chips for things like electric cars. That could actually affect the price you and I pay for them down the road.
And this idea of doing everything in one place, it's so rare and so strategically important that even the European Commission took notice. They called it a first of a kind for the whole region. That's a big statement, and it's exactly why they gave the green light for the Czech government to put in 450 million euros to help get it done.
So, when you step back and look at all the pieces, the smart strategy, the skilled people, the end-to-end control, you realize this is so much bigger than just one company. This one project is literally shifting the center of gravity for high-tech manufacturing across all of Europe.
For the Czech Republic, this is a total game changer. I mean, it's the biggest single foreign investment in the country's entire modern history. But it's more than just money. It changes what the country is. It's moving them from being a place that just assembles cars for other countries to a place that produces the core technology that's going to power the cars of the future. That's a huge shift.
And if we zoom out even more, you can really see the new map taking shape. While some of the big chip plans in Western Europe, like in Saarland, have kind of fallen flat, a powerful new cluster is forming in the east. You've got this huge success with onsemi in Czechia, and you combine that with all the money pouring into Dresden in Germany, and boom, you're looking at the new silicon heart of Europe.
And this shift to the east isn't just a coincidence. It's happening for some very clear reasons. It's like the perfect recipe, right? You've got lower costs, a really strong history of technical education, and governments that get it. They understand how important this industry is and are willing to support it.
You know the drill. For decades, the whole semiconductor industry has been marching to the beat of one drum: Moore's Law. The goal was always to shrink things down, cram more transistors onto a chip, and just make everything go faster and faster.
Okay, but here's the twist. What if that's not the only race in town? What if the real future, the next massive leap, has nothing to do with speed? Well, there's this company out of the UK called Pragmatic, and they're basically running in the complete opposite direction. And I mean, they have completely flipped the script. They're not chasing nanometers, they're chasing pennies. Their whole philosophy, their big bet, is that for the next tech revolution, cheaper is the new faster.
So think about it like this. On one side, you have the old guard, the silicon race, just obsessed with raw performance. And on the other, you have what Pragmatic is doing, focusing everything on cost and flexibility. This is key. They're not trying to build a better race car. They're building something that doesn't even need a road.
So what is this thing? Well, here you go. They call them Flexics.
And get this, instead of going through the incredibly complex and expensive process of etching circuits onto a rigid silicon wafer, Pragmatic prints them right onto these thin, bendy polymer films. And that one move, it gets rid of the most expensive part of making a traditional chip, the silicon itself.
Okay, so why does this matter so much? Because when you make a chip this cheap, you unlock a market that's just mind-bogglingly huge. People are calling it the Internet of Trillions. We're talking about putting a tiny bit of intelligence, a tiny brain, into everyday things that you would never, ever have put a chip in before because it just costs too much.
Yeah, there's a great line that just nails it. You're not going to stick a 50-cent silicon chip on a 10-cent yogurt pot, right? The math just doesn't work. But what if that chip didn't cost 50 cents? What if it cost a fraction of a penny? All of a sudden, the game completely changes. Now you can have smart labels on your food that actually tell you when it's about to go bad. Or think about intelligent bandages that can monitor how a wound is healing. Or packaging that literally tells the recycling plant, hey, I'm this type of plastic, recycle me this way. And this isn't just some cool tech fantasy. This is the stuff you need to build a real, working circular economy. And listen, this isn't some pie-in-the-sky idea stuck in a research lab. Oh no, Pragmatic is making this happen. for real, at a massive scale, right there in the UK.
How real? Well, in late 2023, they pulled in a staggering £162 million in funding. That was the biggest VC round for any semiconductor company in Europe. That's not just a vote of confidence, that's the market screaming, "We believe in this," with serious, heavy hitters like the UK Infrastructure Bank backing them. And they are moving fast. I mean, ridiculously fast. They get the money, and boom. By March 2024, they've opened Pragmatic Park in Durham. We're talking about the UK's first 300mm fab, ready to churn out literally billions of these chips. And then, by 2025, they're already rolling out their next-gen platform. The pace is just incredible.
And that new platform, their Gen 3 tech, it delivered a 10x improvement in power efficiency. 10 times! That just goes to show their R&D is the real deal. They're not just making small tweaks, they're making huge leaps forward.
But honestly, as cool as the chip is, the really profound part of this story might be how it's made. Because Pragmatic's whole model could totally upend the global semiconductor supply chain that we all know is, well, pretty fragile.
Think about it. Right now, everything is super centralized. One problem in one place, say Taiwan, and the whole world feels it. Production just grinds to a halt. Pragmatic's idea is the exact opposite. They call it Fab in a Box. These are small, self-contained production lines you can basically drop anywhere you want. Put one in a warehouse in Manchester, put another one in Mexico, wherever you need it. The strategic payoff here is just huge. First, you get incredible resilience in your supply chain. No more single points of failure. Second, you can make the chips right where you're going to use them. And third, for a country like the UK, this is a massive win for tech sovereignty. Why? Because Pragmatic owns the whole shebang. The machines, the process, the IP. They're not relying on anyone else.
So let's bring it all together. The takeaway is crystal clear. Yeah, the tech is cool, but the really revolutionary idea is so much bigger. This isn't just about a new chip. This is about a whole new blueprint for manufacturing itself.
So that's the big question, isn't it? How on earth did a chip factory end up being flagged as a national security issue? Well, the answer lies in how this facility quietly became one of the most contentious pieces of industrial real estate in the UK.
Okay, so meet our main character, Newport Wafer Fab, or NWF. For years, this place was a pretty unassuming player in the whole semiconductor game. But a change in ownership was about to throw it right into the geopolitical spotlight.
And right here, this is where the alarm bells started to go off for some people. You see, the new owner, Nexperia, is technically a Dutch company, but its parent company, that's Wingtech, which is based in China. And just like that, the UK's biggest semiconductor facility was now under the control of a Chinese-linked company. That, you can bet, raised some serious questions in the halls of government. Now here's the interesting part. The government's concern wasn't really about the chips that were rolling off the line at that moment. Nope. It was all about what that factory could become. The risk they saw was all about future potential.
Let's break this down because it's super important. NWF was making your standard run-of-the-mill silicon chips, but the site itself, the facility, could be retooled to create something way more advanced, compound semiconductors. These are a whole different ballgame. They're essential for things like advanced radar and military communications. So that dual-use potential, the idea that the tech could power both an electric car and a next-gen defense system, that's what really triggered the whole national security investigation.
So, faced with this potential risk down the line, the UK government decided it had to act. They made a really decisive move, using a brand new law to basically force a change in who owned the factory.
And you can see on this timeline just how quickly it all happened. In 2021, the UK brings in this new National Security and Investment Act, which gives it the power to block takeovers. Fast forward to late 2022, and they use that exact power to order Nexperia to sell the factory. And by March of 2024, a new owner is in place, the US-based Vishay Intertechnology. That move firmly anchored this strategic asset right back within the Western Alliance.
But this change of ownership wasn't just some political maneuver. It was basically the starting gun for a massive industrial transformation. All those years of uncertainty were just gone, replaced by this incredibly bold new vision for expansion. Just take a look at that number, £250 million. That is the insane amount of new investment that Vishay is now pouring into the Newport site. It's a huge signal that this factory's future is getting a complete and total revitalization.
So where's all that cash coming from? Well, it's a great example of a public-private partnership. Most of it is coming from Vishay itself, but it's also being backed by the UK government's Automotive Transformation Fund. That's a program designed specifically to help de-risk
These kinds of huge, strategic private investments. So what exactly does a £250 million get you? A complete metamorphosis. To make the new kind of chips, you need crazy high temperatures that the old equipment just can't handle. So they're installing all new furnaces and reactors. The clean room has to be totally rebuilt. I mean, this isn't just an upgrade, it is a fundamental pivot from a general-purpose factory to a highly specialized, cutting-edge facility.
And here's where it gets really cool. This isn't just a story about one factory anymore. Its new mission is directly plugged into the green energy transition, and what it produces is going to have an impact on all of us.
The factory is now all in on making chips from something called silicon carbide, or SiC. You can think of this stuff as the unsung hero of green technology. It's way more robust than regular silicon, which means electronic parts can be way more efficient and powerful.
Let's take an electric car, for example. You've got a crucial part called the inverter, which converts the battery power for the motor. If you switch to silicon carbide chips in that inverter, you can cut energy loss by up to 10%. And trust me, in the world of EV performance, a 10% gain is absolutely massive.
So why should you care? Well, that 10% efficiency boost means longer range for your electric car. It could even mean car makers can start using smaller, lighter, and cheaper batteries. And for the UK, it's a huge win because it means securing a local supply of these critical parts for major players like Jaguar Land Rover and Nissan.
You know, when you take a step back and look at the whole story, the saga of Newport wafer fab starts to look less like a one-off crisis and maybe more like a blueprint, a new playbook for industrial strategy.
And that's exactly how the government itself framed it. When ministers visited the site, this was their big takeaway. They called it proof of their strategy in action, not just dodging a security bullet, but actively steering a national asset towards a high-growth industry that's vital for the future. And that brings us right to Dresden's €5 billion answer. This is Infineon's Smart Power Fab, and let me tell you, it's way more than just a factory. Think of it as a calculated, strategic move toward technological independence. Let's just stop and think about that number for a second. €5 billion. This is the biggest single investment Infineon has ever made in its entire history, which tells you everything you need to know about the stakes. And get this, about $1 billion of that is public money, a government subsidy that was absolutely crucial to compete with incentives from other countries and keep this whole project right there in Germany. And the impact here, it's not just about the tech. This one factory is going to create 1,000 new, high-skilled jobs. But the ripple effect is even bigger. We're talking an estimated 6,000 more jobs popping up in the whole region around it. It's a massive economic engine, and it's all powered by this cutting-edge manufacturing. And check out this timeline. You know how these massive infrastructure projects are almost famous for being late? Well, not this one. It is running like a Swiss watch. From the groundbreaking in 2023 to the planned production start in late 2026, they are hitting every single milestone. That kind of precision just shows you how seriously Europe is taking this race. So, the factory is on time, which is awesome. But what is it actually going to make? Well, its first huge job is to power the AI revolution. But maybe not in the way you're thinking. We're not talking about the AI's brain here, but something that's just as vital. This brain versus muscle analogy is just perfect. We all hear about the AI brain, right? Those super powerful GPUs from companies like NVIDIA that do all the heavy lifting and complex calculations. But for that brain to do anything at all, it needs muscle. And that muscle is the power semiconductors that this factory is going to make. They manage and deliver electricity with incredible efficiency. And this quote just nails it. The most powerful AI brain on the planet is totally useless without the muscle to power it up. So this factory, it isn't just making some random component. It's building the absolute foundation for the entire AI data infrastructure. And here's what happens in the real world if you don't have them. AI data centers are insanely power hungry. Without these hyper-efficient power chips, they'd either just overheat and completely fail, or their energy consumption would go through the roof, becoming totally unsustainable. These little chips are literally the difference between a working AI and a fried server. But hey, this factory's impact doesn't stop with AI. It's also about locking down the future for another crown jewel of the European economy, the auto industry. I mean, this chart really says it all. As cars become these software-defined vehicles, which are basically just powerful computers on wheels, the value of the chips inside them just skyrockets. We're talking a jump from around $500 in a traditional car to over $1,500. That is a massive surge in demand. So why is making these chips in Dresden such a game changer? It's all about one thing:
location, location, location. This factory is just a few hours' drive from major German auto plants. That creates a local, just-in-time supply chain. It means car makers aren't sitting around waiting for a boat from the other side of the planet. It's a powerful shield against those global supply chain shocks that can paralyze an entire industry.
So when you zoom out and look at the big picture, you see this is about so much more than just one building. It's a strategic asset in a global tech race. It's Europe planting a flag and declaring, we are going to control our own technological destiny.
And in fact, this project is pretty much the EU CHIPS Act in action. It directly addresses what they call Pillar 2, security of supply. And that's a policy that's all about one thing, making Europe stronger so it doesn't have to rely on other regions for this super critical technology.
All right, let's get right into it. When we talk about computer chips, we usually think of the huge, flashy names. But today, we're looking at a massive, high-stakes bet being made in a part of the supply chain that's absolutely critical, but often flies under the radar. And that number is 372 million euros, or, put another way, roughly 400 million US dollars. Now, this isn't the budget for the next summer blockbuster. This is the price one single company is paying just to stay in the game to secure its future in a world that is getting more competitive by the minute.
So what does it really cost to compete in the global chip market today? Well, for this one company, the answer is a $400 million bet the farm decision that they were pretty much forced into. Let's break down exactly who's making this enormous wager, and more importantly, why.
Our story kicks off in Germany, with a company that finds itself at a massive crossroads. And honestly, it's a position that a lot of companies in these essential, but maybe less glamorous industries are facing right now.
Meet Vishay. They're based in Tahoe, Germany, and they work in the mid-market of the semiconductor world. Now, they don't make those headline-grabbing, super advanced chips, no. They make what's called mature technology. Think of them as the workhorses, the proven, essential chips that power countless devices we use every day, from our cars to our kitchen appliances. And right now, they're sinking nearly $400 million into a brand new factory for what are called 300mm wafers. And get this, they are moving at an absolutely incredible speed. Just look at this timeline. They broke ground in March of 2023, and they expect to be running their first test wafers by 2025. I mean, that is a blistering pace for this industry. It just screams urgency. So you have to ask, what's the big rush?
Well, this hurry wasn't just about chasing some new opportunity. It was born from intense pressure. Think of it as a strategic squeeze coming at them from two completely different directions at the exact same time.
So on one side, you have fierce, cutthroat market pressure. Chinese manufacturers are just flooding the market with legacy power chips, the exact kind of reliable, older generation chips that are Vichay's bread and butter. Then, on the other side, the government funding they might have hoped for from things like the EU CHIPS Act, well, it's moving way too slowly. And even worse, it tends to go to the flashy advanced nodes, the super cutting-edge stuff, not the essential, mature technology that Vishay makes.
This quote from Vichay's own management just hits the nail on the head. It perfectly captures their dilemma. They're trapped. They're too important to the supply chain to just disappear, but they're not fancy enough to get priority help. They realized they couldn't just wait around for a rescue. They had to save themselves. And oh boy, did they act. Their response was a bold, two-part strategy they're calling Vishay 3.0. It's their playbook for survival, and it's their huge gamble on the future.
They've actually described this plan as brutal but necessary, which, that tells you everything you need to know about the stakes here. The first part of the plan is a massive technological leap forward, one designed to outmaneuver their rivals on pure, raw efficiency. Okay, quick primer so we're all on the same page. The heart of all chip making is the semiconductor wafer. It's basically a super thin disk of silicon where all the magic happens. The key thing to know, the bigger the wafer, the more chips you can cram onto it at once.
And this right here, this is Vishay's masterstroke. They're moving from the old standard 200mm wafers to new, much larger 300mm ones. Now that might not sound like a huge jump, but that increase in diameter more than doubles the available area. The result? They can print 2.25 times as many chips in a single run. That's a game-changing economy of scale. It's their weapon against that flood of cheaper competition.
But a hyper-efficient factory like this costs a fortune. And that brings us to the second and much more brutal part of the Vishay 3.0 plan. To feed this new, giant beast they're building in Idaho, they have to starve their other operations.
Yeah, to fund this one new site, Vishay is closing its older, smaller plants all around the world.
As this timeline shows, facilities in Germany, the United States, and even China are all getting shut down between 2025 and 2026. They are literally sacrificing their entire global footprint to create one single, ultra-efficient super campus.
Which brings us to the bottom line of this huge gamble. After all this, what has Vishay gained? And just as important, what have they lost? It's a classic business trade-off, really. Efficiency versus risk. And it's one that has huge implications for our global supply chains.
So on the pro side, the new campus in Idaho is going to be an absolute powerhouse of efficiency, able to compete with anyone on a global scale. But on the con side, and this is a big one, they've completely abandoned geographic diversity. By putting all their eggs in one German basket, they've created a single point of failure for their entire company. A local crisis, a flood, a power outage, anything could become a global catastrophe for them.
So here's the crucial point, the thing to really take away. Vishay made a calculated choice. They have traded the resilience that comes from having factories all over the world for the raw power of hyper-efficiency, all concentrated in one spot.
So what do you do when you can't just keep shrinking things? Well, the whole mindset has to shift. If you can't build down anymore, you've got to build differently. The industry's focus isn't on making chips smaller now. It's all about how you can cleverly combine them. And this new frontier, it's called advanced packaging. So forget that old idea of one single, giant, monolithic chip. Instead, think of it more like high-tech Lego. You're stitching together this quilt of smaller, specialized chips, they call them chiplets, to create one super powerful processor. And here's the really important part. This whole process, which used to be seen as just some low-value assembly work, is now just as critical and high-tech as actually making the chip itself. It's a total game changer.
Okay, now check this out, because this really shows you Europe's big weak spot. You could have a chip designed in the UK, right? Then it's built in a super advanced factory in Germany, but then it had to be flown halfway across the world to Malaysia or Taiwan just for this final critical packaging step. I mean, can you believe that? This created what people are calling a gaping hole in Europe's tech sovereignty. Basically, its ability to control its own destiny.
So how do you plug a hole like that? Well, that brings us to the first part of Europe's strategy. It's this hugely pragmatic investment, and it's all happening in northern Italy.
And here's the big player, a company called Silicon Box. They're a Singaporean tech unicorn founded by the same people who created Marvell Technology, so they're a big deal. And in this really landmark move, they've picked Italy for their very first major facility outside of Asia. I mean, that's a huge vote of confidence in Europe.
And just look at the scale of this thing. It's absolutely immense. We are not talking about some small pilot program here. This is a total investment of 3.2 billion euros. But get this, it isn't just a private venture. To make sure this first-of-its-kind facility landed in Europe, the European Commission actually approved 1.3 billion euros in state aid from Italy. So it's a really powerful public-private partnership.
And it goes beyond just the tech. You know, this is a huge investment in people. This facility is going to create 1,600 new, highly skilled jobs. That's going to build a critical talent pool in that region for years and years to come.
So what makes them so special? Well, this is where their technological edge really shines. Instead of using those traditional round silicon wafers you always see, Silicon Box uses these large, rectangular panels. Now that might sound like a small change, right? Just the shape? But no. It allows them to be 6 to 8 times more efficient than the standard methods. It is a genuine game changer for manufacturing.
So, the big question is, how quickly is this actually going to make a difference for Europe? Well, let's look at the timeline. Construction is going to kick off in 2025, the first chips will start rolling off the line in early 2028, and then the plant should be running at full capacity by 2033. So yeah, it's a long-term play, but the pieces are definitely moving right now.
And the strategic impact here? It's huge, profound, really. For the very first time, a cutting-edge processor can be designed, built, and finished entirely within Europe. That gaping hole we talked about in the supply chain? Consider it officially sealed.
But hold on, because securing today's supply chain is only half the battle. That's just prong one of the strategy. Europe is also making a really bold bet on inventing the technology of tomorrow. And for that story, we need to head to Spain. Here, we're talking about IMEC. Now, if you're not familiar, IMEC is a Belgian research powerhouse, and you could argue it's the most important semiconductor research institute in the entire world. They're setting up a brand new R&D facility down in Malaga, Spain, and listen,
This has nothing to do with mass production. This is all about pioneering the tech of the next century.
See, Spain isn't trying to compete with Italy or Germany on manufacturing volume. That's not the point. Instead, it's positioning itself to lead the next great wave of computing. And the goal here is, well, it's radical. It's to merge the worlds of biology and silicon, and they're doing it by leveraging Malaga's existing strengths in biomedicine.
Now, what if I told you that the entire mission of this massive, multi-million euro facility could be boiled down to just one single jaw-dropping number? $10.
$10? What on earth for? Well, that is IMEC's target cost to sequence a complete human genome. The plan is to develop these revolutionary new chips that use light, it's a field called photonics, to create microscopic fluid channels and sensors, and build it all using standard silicon manufacturing. And just think about the impact of hitting that $10 target. It would be absolutely staggering. We're not just talking about an improvement, it would fundamentally revolutionize personalized medicine, making treatments tailored to your own DNA accessible to literally everyone. Okay, so let's step back. We have two very different projects, right? One in Italy, focused on manufacturing for today, and one in Spain, focused on research for tomorrow. But the key thing to understand is that these are not separate bets. Nope, they're two sides of the very same coin. And this comparison really lays out the brilliant dual strategy. Look, on one hand, you've got Italy. The goal, secure the present. The focus, commercial manufacturing. They're using advanced packaging to complete that supply chain right now. Then, on the other hand, you have Spain. The goal there, invent the future. The focus is pure R&D, creating the next generation of computing by merging biology and silicon. So one project ensures Europe can build what it needs now, while the other ensures it'll be leading the world in what comes next. It's a beautiful strategy.
Which of course brings us to the ultimate question. This is an ambitious, it's sophisticated, and yeah, it's an incredibly expensive strategy. But is it going to be enough? Can Europe truly win the chip race with this plan?
So, Europe's got this massive plan, right? They're calling it chip sovereignty. They're pouring billions and billions into becoming a semiconductor superpower. But is it actually working? Well, there's one story about $1 billion factory that reveals a huge, really uncomfortable truth at the very heart of this whole strategy. Okay, let's get into it.
So picture this. It's 2023, and there's this fantastic news. The US chip giant Broadcom announces they're going to build a massive $1 billion facility in Spain. And of course, the Spanish government was ecstatic. They hailed it as this strategic masterpiece, a huge win for their national chip plan. And then, poof, just as quickly as it appeared, the whole dream just vanished. By the middle of 2025, the entire project was officially canceled. Gone. $1 billion deal, a cornerstone of the strategy, just gone. So what on earth happened? Now look, this wasn't just some business deal that went sideways. The collapse of this Broadcom project is a huge red flag. It exposes some really critical cracks in the very foundation of Europe's entire chip strategy. And just look at how fast it all fell apart. You go from the celebrated announcement in 2023 to a complete cancellation just 2 years later. This wasn't some slow, predictable decline. It was like hitting a brick wall. All right, so to really get why this is such a big deal for all of Europe, we got to do a little detective work. We need to look at the anatomy of this failure, because it turns out it wasn't just one single thing that killed this project. The deal basically unraveled because of a perfect storm of 3 fatal flaws. You had global politics shifting, a major fight over money, and then this harsh industrial reality that everyone seemed to overlook. Let's break these down one by one. First up, politics. You know, as the US started seriously considering new tariffs and pushing these America First policies to bring manufacturing back home, the risk factor for a US company like Broadcom to build a huge new factory in Europe, well, it just shot through the roof. The political winds were changing fast, and that created massive uncertainty. Second, you have a classic fight over cash. The Spanish government wanted to pay out its subsidies in stages, over time. But Broadcom needed a giant pile of capital right now to buy all the incredibly expensive equipment. And this clash over cash flow became a major sticking point they just couldn't get past. And this brings us to the third and maybe the most critical flaw. You see, you can't just plop a high-tech factory down in a vacuum and expect it to work. A place like Dresden in Germany has a 30-year-old ecosystem built up around it, a whole network of suppliers and specialized engineers. Spain, on the other hand, was a lone outpost. Broadcom realized it would be a logistical nightmare and super expensive to operate there all by itself.
Okay, so let's zoom out. Because what happened in Spain isn't just about Spain. It actually reveals something much bigger. A deep structural divide that runs right through the heart of Europe's entire industrial strategy. People who study this call it two-speed Europe. And the Broadcom failure is a textbook example. You've got this established industrial engine up in the north, built on decades of infrastructure that just acts like a magnet for new manufacturing. And meanwhile, the South often gets left with R&D roles or has to use massive amounts of public money just to try and build something new from scratch.
And you can see that split pretty clearly right here. The original vision was for all this cool, high-tech manufacturing to be spread out evenly across the whole continent. But the reality? It's a clear consolidation of industrial power in the north.
But wait, the story doesn't end there, because a 2026 audit of Europe's entire semiconductor scene revealed something far more alarming. It uncovered the massive, uncomfortable truth that all this investment still hasn't fixed. So here's the number you really need to remember: 100%. Despite mobilizing nearly $100 billion, Europe remains completely 100% dependent on two companies in Asia, TSMC in Taiwan and Samsung in Korea, for the most advanced, leading-edge chips. And why is that such a big deal? Because we're not talking about the chips in your coffee maker. These are the brains behind, well, everything. They power our iPhones, they train AI like ChatGPT, and they're absolutely essential for advanced defense systems like autonomous missiles. We're talking about the absolute cutting edge of technology here. And here, right here, is the gut punch. After all the big announcements, all the subsidies, all the political speeches, none of the new investments are actually set up to produce these critical, leading-edge chips in Europe. The core vulnerability? It's still there, completely untouched. The one project that was supposed to fix this, the big Intel plant in Magdeburg, has been hit with delay after delay and a lot of skepticism. It is left, as one report perfectly put it, a hole in the heart of the CHIPS Act. All right, so let's start with Italy's Silicon Revolution. For almost half a century, this GlobalWafers site in Novara has just been, well, a steady producer, kind of chugging along. But this new Fab 300, this is not just some simple upgrade. No way. It's a massive, complete leap straight into the future of tech. Now, you might look at this and think, okay, 200 millimeters to 300 millimeters, so what? It's just a bit bigger. And yeah, it might seem like just a small change in geometry. But in the semiconductor world, this isn't just about size. It's literally the difference between two completely different eras of technology. So yeah, that 300 millimeter wafer, it's not just an option, it is the standard, the undisputed king. Seriously, our entire modern tech world, everything we rely on, is built on this exact platform. So what does that really mean? Well, we're talking about the absolute bedrock of modern tech. Think about the advanced logic, the actual brains inside our computers, or the processors that make your smartphone so fast, or even the high-density memory that holds all your photos, your apps, your entire digital life. It all starts here. And here's the real kicker. Before this new factory came along, European chipmakers had a huge problem. They had to import these advanced wafers, these substrates, all the way from Asia. So this new fab, it's literally plugging a massive gaping hole in Europe's entire tech supply chain by bringing this critical piece home. So how do they even make these things? Well, what's going on in Italy is way more than just manufacturing. It's this incredible vertically integrated process. It's almost like a kind of high-tech alchemy. And the craziest part, it's all happening right there, inside Italy. The magic word here is vertical integration. And all that really means is that GlobalWafers isn't just doing one little piece of the puzzle. Nope, they're controlling a bunch of the most important steps in the production line all in one place, right there in northern Italy. And let me tell you, that is a massive strategic advantage. Okay, check out this journey. It's pretty wild. A wafer doesn't just start out as a shiny disk. It begins its life in a town called Murano, where they melt down super pure silicon and grow it into this perfect crystal cylinder called an ingot. The method they use is so mind-bendingly precise that people in the industry call it a dark art. Then they take that ingot over to the new Fab 300 in Novara. There, it gets sliced up, polished to perfection, and finally goes through one last step called epitaxy.
So what the heck is epitaxy? The best way to think about it is like applying the final, absolutely perfect coat of varnish on a priceless piece of art. It's the process of growing a totally flawless new crystal layer right on top of the wafer. And you have to have this step if you want the kind of high-performance chips that run our modern world. So what's the big deal about keeping this whole process from that first crystal to the finished wafer all inside Italy? Well, the payoffs are huge. For one, it slashes transportation costs and the carbon footprint. But maybe the biggest win of all? It protects the supply chain from all those crazy global disruptions that, let's be honest, we've all gotten a little too used to lately. And that leads us perfectly into the bigger picture. We need to zoom out here because this factory isn't just a smart move for one company. It's a really important piece in a much, much larger strategic puzzle for all of Europe. What you're saying here is the European Chips Act in action. This isn't just theory or policy papers. The FAB 300 project is a textbook example of how this huge government initiative is actually playing out on the ground, directly fueling Europe's quest for tech independence. And, money talks. The partnership here is really key. We're talking about a total investment of 450 million euros. And as you can see, while GlobalWafers put up most of the cash, a really significant chunk, 103 million euros, came from public funding from the EU. That shows you just how serious both sides are about this. And that grant money, it was absolutely crucial. Think about it. That funding covered almost a quarter of the entire cost. That's what made it possible for GlobalWafers to say yes to building in Europe, which is expensive, instead of just taking the easier, cheaper route and building in Asia. It took a lot of the risk off the table. Okay, let's zoom out one more time because this story gets even bigger. The impact of this factory goes way beyond just money. We're talking about global politics and the environment now. People are actually calling this silicon diplomacy. And what they mean is that this collaboration between a huge Taiwanese tech company, GlobalWafers, and Italy is a big deal politically. In an industry that's usually full of tension and competition, this project is a shining example of how countries can work together, and it's making the economic ties between Taiwan and Europe a whole lot stronger. The company's own chairperson, Doris Hu, said it best when they opened the factory. She didn't just talk about making chips. She called it a symbol of innovation, sustainability, and shared growth. That's a pretty powerful vision. And that whole sustainability thing, it's not just lip service. This factory was built from the ground up to hit the RE100 standard, which basically means they're committed to using 100% renewable energy. Plus, they recycle about half of their water, which is a really big deal in a region that's often worried about water shortages. And look, this isn't just about feeling good. It's a brilliant business move. It means these wafers made in Italy are a premium, low-carbon product. And who wants that? Well, a lot of customers, especially big European car companies who are now legally required to track the carbon footprint of every single part in their supply chain. Okay, so picture this. Way out in the French Alps, there's this one company, and they're perfecting this tiny little wafer that could be the key to solving one of the biggest headaches for electric cars. This is one of those classic stories, hitting a wall with technology, and then some brilliant innovation comes along and just smashes right through it. All right, so to really get this, we have to start with a problem that honestly affects every single piece of tech you own. For decades, we all kind of live by this simple, unspoken rule. Computers just get twice as powerful, like every 2 years. But what happens when that rule starts to bend? What happens when it breaks? Now, this isn't the first time we've hit a wall like this, not by a long shot. And the company that's at the center of this whole story, a company called Soitec, well, they've already solved this exact kind of problem for a device that's probably in your pocket right now. They did it with something called silicon on insulator, or SOI for short. Basically, what Soitec figured out how to do was to slip this super thin, microscopic insulating layer right inside a silicon wafer. It sounds kind of simple, right? But what it does is it stops electricity from leaking out, which is a huge source of wasted energy in pretty much all standard chips. And the result of that one little change? Well, that technology is now the global standard for the radio frequency chips in basically every single smartphone. It's what makes the 4G and 5G we all rely on even possible. So you see, Soitec has a serious track record here. They solve massive energy efficiency problems on a global scale. Okay, so now they're taking that same kind of thinking and aiming it at an even bigger challenge: the incredible, massive power demands of the electric vehicle revolution. Because in the world of electric cars, the whole game has changed. The new currency, the thing that really matters, it isn't horsepower anymore.
its range, and its charging speed. And guess what? Both of those things are pretty much entirely dictated by how efficient the power electronics are. You know, the stuff that manages all the energy flowing between the battery and the motor.
And this is where good old-fashioned silicon just can't cut it. It really struggles with the super high voltages and all the heat inside an EV's powertrain. The ideal material for this job is something called silicon carbide, or SiC. I mean, this stuff has a structure kind of like a diamond, and it can handle crazy high voltage with way, way less energy loss. But, and this is a huge but, there's a massive catch. Growing these SiC crystals is incredibly hard and super expensive. It just makes the wafers too pricey for a mass market car. So let's get this straight. We've got the perfect material, but it's just too expensive to actually use. This is where Soitec's genius really kicks in. They came up with this breakthrough process that basically makes the impossible possible.
They call their proprietary technology Smart Cut, and it's been described as something like an atomic scalpel. I mean, just think about that for a second. It allows for a level of precision that's almost impossible to wrap your head around.
Okay, so how does this atomic scalpel actually work? Well, first, they take one of those super expensive, really high-quality SiC wafers, and they slice off this microscopically thin layer. That's the only part that actually matters for performance. Then, they take that perfect little slice and they bond it onto a much, much cheaper carrier wafer. And here, this is the truly brilliant part. The original expensive wafer gets polished up and is ready to be used all over again.
And we're not talking just once. They can reuse that same donor wafer more than 10 times. This is just a masterclass in resource efficiency. It completely slashes the cost of the final product.
But the benefits don't even stop there. It's not just about cost. Because the process is so ridiculously efficient, these smart silicon wafers cut carbon emissions from production by a staggering 75% compared to the old way of making them. So it's cheaper and it's cleaner. That's a huge win.
Okay, so this one piece of tech has implications that go way beyond just one company. This is actually becoming a cornerstone of Europe's entire strategy for the future of its auto industry. It's a massive move to secure its own technological independence, its own sovereignty.
And Soitec is betting big. We're talking an investment of around 400 million euros in a brand new fabrication facility. This isn't just some simple expansion. No, this is a huge strategic move aimed squarely at the automotive sector.
And what's the goal here? To churn out 500,000 of these smart SiC wafers every single year by 2030. That is a massive volume. And it's designed for one specific reason: to meet the exploding demand from the European EV market, and, crucially, to rely less on foreign supply chains. You know, an innovation like this doesn't just happen in a vacuum. Soitec is based near Grenoble in an area people call the Silicon Valley of the Alps. And they work inside this really unique lab-to-fab ecosystem. They collaborate with world-class government research institutes like CEA Linde to take an idea from the lab and accelerate it all the way to industrial-scale production. So here's how this whole supply chain just locks together perfectly. The research kicks off at CEA Linde, Soitec takes that and produces the advanced wafers. Then those wafers go to European chipmakers like STMicroelectronics and Infineon. They turn them into the critical power electronics that then get supplied to automakers like Volkswagen, Stellantis, and Renault. You see? This whole investment is basically a direct lifeline for the entire European EV industry. It's what ensures they can actually compete on the world stage.
This analogy right here, it's the perfect way to think about chip manufacturing. A microchip, it starts as this blank silicon wafer. That's your canvas. But to create all those complex circuits, you have to add, etch, and polish hundreds of different layers. And that's where the chemicals come in. They are the paints and the brushes that turn a simple canvas into a straight-up technological marvel.
And the quality of that paint has to be, well, it has to be unbelievably pure. We're talking about purity at the parts per trillion level. Now, to give you an idea of what that means, that's like trying to find one single drop of ink in 20 Olympic-sized swimming pools. A single microscopic flaw, a particle so tiny it's hard to even imagine, can completely destroy a multi-million-dollar chip. The stakes are just incredibly high.
So in this world of extreme high-stakes precision, the German science and technology giant Merck, KGaA, which by the way operates as EMD Electronics over in North America, is a global hegemon. They are true masters of this molecular world.
Okay, so a few years ago, the industry entered what's known as a supercycle, basically a period of intense, sustained demand. You know, the explosion of AI, the Internet of Things, big data, it all created this insatiable appetite for more and more powerful chips.
And Merck, recognizing this massive shift, didn't just plan to keep up. They launched a super ambitious growth program they called Level Up.
And they are backing this plan up with some serious capital. The Level Up program is committing the company to investing over €3 billion by 2025. That is a huge statement of intent.
Now, this money isn't just for keeping the lights on. It's really a two-pronged attack. On one hand, they're pouring money into innovation to create the materials of the future. And on the other, they're dramatically expanding their capacity to produce the materials we all desperately need today.
And this is a very focused, strategic push with a clear timeline. By launching in late 2021 and aiming for completion by 2025, Merck is trying to not only capture the momentum of this current supercycle, but also to position themselves as the leader for whatever comes next.
And this quote, this really reveals the sheer scale of their ambition. Their goal isn't just to be a top supplier. No, it's to become the premier molecular architect of the digital age. What does that mean? Well, they see themselves as the ones designing and building the very foundation of our entire technological future.
So how are they actually executing this grand vision? Well, it's not about putting all their eggs in one basket. Instead, they're creating this powerful and resilient global triad of major hubs, and each one has a very specific and crucial role to play.
The brain of the whole operation is in Darmstadt, Germany. This is where the R&D happens. They've built an electronics technology center that's pretty much a mini version of a customer's factory. It's like having a test kitchen where they can perfect their recipes before setting them out to the world's top chefs. It just dramatically speeds up development. And they're also building a new €62 million quality control facility to make sure their materials meet those mind-boggling purity standards we talked about.
All right, the next part of the triad is in Taiwan, with a massive €500 million investment in a new mega site. The strategy here is actually pretty simple. To be the best, you have to be close to the best. By setting up shop right next to giants like TSMC, they gain all this invaluable knowledge and insight that feeds directly back into their R&D in Germany. It's a brilliant feedback loop.
And the third hub is in the United States, with a €300 million investment in Pennsylvania. This facility is set to be the world's largest for something called specialty gases. These are the ultra-pure gases used to create the perfect, sterile environment you need for chip manufacturing. They're a critical, absolutely non-negotiable ingredient, and this move helps secure that vital part of the supply chain.
So, what does this whole global triad create? Well, Germany, Taiwan, and the USA give Merck what's called a follow-the-sun capability. It means they're always on, always producing, always innovating. If a crisis hits one region, the others can pick up the slack. And for their customers, this means a rock-solid, secure supply of the materials that are basically the lifeblood of their business.
But look, having a global reach is only half the battle. The other pillar of Merck's strategy is to become an indispensable all-in-one partner for the chip makers. They did this through some really smart acquisitions like Versa Materials and Intermolecular. This gave them one of the most complete portfolios in the entire industry. They can now supply pretty much everything, from the materials that insulate the tiny wires on a chip to the high-tech slurries that polish the wafer to a perfect mirror-like finish.
This slide really gets to the heart of their value proposition. Okay, imagine you're running a chip factory. You could try to juggle a dozen different suppliers, just praying that all their different chemicals actually work together, or you could go to Merck, a single partner that understands the intricate dance between every single material. It's a huge, huge advantage in terms of efficiency and reliability.
By becoming that single source of expertise, Merck transforms from just being a simple vendor into something much, much more. They become a part of their customers' DNA, a true partner in creating the future of technology.
All right, so let's zoom out for a second and connect the dots. What does this highly coordinated, multi-billion-dollar strategy all add up to?
It means that every single move, from the labs in Germany to that global network of hubs to their all-in-one portfolio, it's all part of a single, coherent plan. It's a plan designed to make Merck an absolutely indispensable part of the technological infrastructure that our entire world depends on. Their success is directly linked to the reliability of the devices in all of our hands.
Just think about that for a second. The very air that keeps you and me alive is basically a poison when you're trying to make a computer chip. This one single idea has spawned a massive, super specialized global industry that works completely behind the scenes. So before we can even start talking about the giant companies involved, we really have to get our heads around the fundamental problem they're all trying to solve.
At the end of the day, it all comes down to creating this perfectly pure, sterile atmosphere where these tiny, powerful microchips can be born. Now, when we say gases, I'm not talking about what you fill a party balloon with. No. These are industrial gases, and they are purified to a level that is almost impossible to imagine. They are the essential, precisely controlled materials that have to replace normal air inside a semiconductor fabrication plant, or what everyone in the industry just calls a fab. And each gas has a very specific job to do. Nitrogen, well, that's the real workhorse. It's used constantly to flush out equipment and stop any unwanted chemical reactions. Then you've got hydrogen, which kind of acts like a delivery truck, carrying other materials, and it even helps repair the delicate silicone crystals. Oxygen is used to grow these impossibly thin layers on the silicon. And then you get to the really rare stuff like argon and xenon. They are absolutely crucial for the high-tech lasers and plasmas that actually carve out the chip circuits. So, how on earth do you supply this stuff? Let's take a look at our first industrial titan, Air Liquide. They're making a massive strategic bet on building the physical foundation for Europe's chip ambitions, and it's all centered in a place they call Silicon Saxony. Air Liquide just recently announced they're dropping over 250 million euros to build these incredible, state-of-the-art gas production facilities in Dresden, Germany. And look, this isn't just some big number. It is the single largest investment Air Liquide has ever made for the electronics industry in Europe. Ever. But here's the really clever part. This investment isn't just for one customer. Nope. What they're building is an entire utility network to serve the whole area. We're talking about giants like TSMC, GlobalFoundries, Bosch, and Infineon, all plugging into this new infrastructure. Air Liquide is basically positioning itself to be the essential utility provider for the entire region. And this shows you their strategy perfectly. By building out this massive network of pipelines, they make gas delivery incredibly efficient and reliable. You don't need thousands of trucks driving around anymore. This creates a powerful lock-in effect. See, once that infrastructure is in the ground, it becomes way more attractive for other chip makers to move in, which kicks off this virtuous cycle that makes the whole cluster stronger. It's brilliant, really. And this is why reliability is absolutely everything. A supply interruption, even for just a few seconds, can completely destroy entire batches of silicon wafers. We're talking millions of euros worth of product, just gone. So the reliability that these new super automated plants from Air Liquide provide is just as critical as the gas itself. Okay, so that's Air Liquide playing the long game with infrastructure. Now let's turn to the other giant in this space, Linde. While Air Liquide is all about scale and infrastructure, Linde is really pushing the envelope on the technology and sustainability side of things. And they're doing it with something called green hydrogen. You see, for the longest time, the hydrogen used in fabs was gray. That means it was produced from natural gas in a process that, you guessed it, emits CO2. What Linde is pioneering is green hydrogen. This uses renewable electricity to split water into hydrogen and oxygen. The only byproduct? Pure oxygen. Pretty cool, right? And this isn't just a theory they're cooking up in a lab somewhere. Nope. Linde has already built and is operating a 2-megawatt electrolyzer plant at an Infineon's chip fab in Austria. This is a huge, real-world proof of concept for the whole industry, showing that you can actually produce green hydrogen reliably, right there on site. But the big question was always, could it be clean enough? The standards are just insane. And the answer is a massive, definitive yes. This project proved that green hydrogen can be purified to the 9 nines, or 99.9999999% purity level that chip manufacturing absolutely demands. This is a huge deal for lowering the carbon footprint of all our electronics. So beyond all this innovation, both of these companies are tackling a massive geopolitical problem: how to secure Europe's incredibly fragile supply chain for some of the rarest materials on Earth. This is a key part of big initiatives like the EU Chips Act. The war in Ukraine sent a huge shockwave through the system. You see, before 2022, Ukraine was a major global supplier of neon, a gas that is absolutely essential for the lasers used to print circuits on chips. The war instantly exposed this critical weak point in the global supply chain, and everyone panicked. So in response, companies like Air Liquide and Linde have been aggressively building up resilience. They're diversifying where they get this stuff, moving to politically stable regions. They're investing in new production facilities, like a new plant Linde is building in the US. and they're developing really advanced tech to recycle these precious gases. All of this helps make sure that European fabs are protected from the next global shock. So as we start to wrap this up, it becomes pretty clear that these companies are way more than just suppliers. They are the invisible enablers of our entire digital world. They provide the critical things that the whole semiconductor ecosystem needs to actually thrive. You've got Air Liquide providing that large-scale infrastructure and rock-solid reliability. You've got Linde pushing the boundaries of tech and sustainability. And together, they are building the supply chain resilience that Europe desperately needs to compete with the US and Asia. And really, that's the main takeaway here. All the big talk about Europe's technological sovereignty, its goal to be a leader in designing and building the next generation of chips, well, it would all be completely impossible without this invisible infrastructure making sure there's a constant, ultra-pure and reliable supply of these industrial gases.
All right, let's dive right in. The company we're talking about is Shin-Etsu Chemical. It's a Japanese company that, doesn't just supply the tech industry. No, it's more like it is the very foundation the whole thing is built on. To really get what I mean, you have to see this. Okay, just look at this. This chart shows a crazy amount of market power. We're talking about silicon wafers. Think of them as the literal canvas for every single microchip made. And as you can see, Shin-Etsu and its rival Sumco pretty much have a complete stranglehold on the market. This isn't just a big deal. This duopoly gives them unbelievable leverage over the entire global electronics industry. So the big question is, how did they build this empire? And maybe more importantly, why are they suddenly making these huge moves in Europe? Well, here's how we're going to break it all down. First, we'll look at their role as the undisputed Silicon King. Then, we'll see how that centralized empire started to crack. We'll explore their solution, the dual-based strategy. After that, we'll check out a little-known but crucial hub in Europe. And finally, we'll look at why Germany is their next frontier. All right, first up, the undisputed Silicon King. Let's really wrap our heads around just how powerful Shin-Etsu is. Because, it's not just about those silicon wafers. Oh no, their dominance runs way deeper than that. So yeah, they are the #1 supplier of silicon wafers. But that's just the start. Shin-Etsu's a chemical powerhouse. They make other absolutely critical stuff like photoresists, that's the light-sensitive gunk used to literally etch the circuits onto the chip, and they even make the materials that wrap around and protect the finished chips. I mean, they are involved at pretty much every single stage of the process. Now, for decades, this whole empire was built on a strategy that was, super simple, really powerful, but as it turns out, deeply, deeply flawed. The whole idea was to centralize everything. I mean, everything. All their production was in this massive plant in Japan, the Naoatsu plant, and they'd just export to the rest of the world from there. And sure, it was incredibly efficient, but it also created a massive single point of failure for, the entire global tech supply chain. And in 2011, that single point of failure wasn't just a theory anymore. It was catastrophically exposed. The massive Tohoku earthquake, that was the wake-up call. And not just for Japan, but for all of Shin-Etsu's customers all over the world. It proved beyond a shadow of a doubt that this centralized model was just way too risky. Okay, so this crisis basically forced them to go back to the drawing board and rethink, everything. They absolutely had to find a new way to guarantee their supply chain no matter what happened. And what they came up with is something they call the dual base philosophy. The idea itself is actually pretty simple, but it's also profound. It just means that all of their critical materials must be manufactured in at least 2 totally separate places on the globe. That way, a disaster in one region can never, ever shut down production for their customers. And this really shows you the pivot perfectly. They went from the old strategy of centralization to this new dual base idea. And this wasn't just some small tweak, it was a complete paradigm shift. They moved away from the old just-in-time model, which is all about efficiency, to a new just-in-case model that's all about security and reliability. For their customers around the world, this was an absolute game changer. So, how does this whole dual base thing actually play out in the real world? Well, let's take a look at a place you might not expect. A surprisingly vital facility they have in Livingston, Scotland. This is where we see it in action. Yeah, this quote really gets right to the heart of the matter. Think about it. If you're a car manufacturer in, say, Stuttgart, you absolutely cannot afford to have your entire production line grind to a halt because of a typhoon in Japan. It's just not an option. You need a local, reliable supply. And that is exactly what that plant in Livingston provides. Now, here's an interesting detail. this plant in Scotland, it makes smaller wafers than the kind you'd find in the latest and greatest smartphone. So, you might be thinking, wait a minute, isn't that just old tech? Well, the Livingston facility specializes in these 200mm wafers. And you're right, they aren't used for those bleeding edge processors. But are they obsolete? Oh, not even close. In fact, you could argue they're more important now than ever before. See, these 200mm wafers are actually the gold standard for something called power semiconductors. These are the specific chips that manage all the electricity in things like electric vehicles, wind turbines, and industrial robots. And with Europe going all in on its Green Deal, the demand for these exact wafers is absolutely skyrocketing. Okay, so with that solid foundation already built in the UK, let's turn to their next move. Let's see how Shin-Etsu is taking that same dual base logic and using it to push right into the industrial heart of continental Europe, Germany. So the company recently announced this pretty big investment in Germany, about 65 million euros. Now, on the surface, the press release says it's for their pharmaceutical business. But if you look a little closer, you start to see this is a really clever strategic move that's setting the stage for their semiconductor ambitions down the road. It's a classic move, really. What they're doing is investing in one area, pharmaceuticals, to build out all the boring but necessary stuff in Germany. You know, the physical infrastructure, the legal paperwork, the local know-how. This creates the absolute perfect launchpad to then, later on, localize production for their high-tech electronic materials. And this move just happens to align perfectly with Europe's own big push, the EU Chips Act, which is all about bringing chip manufacturing back to the continent. This puts Shin-Etsu in the perfect position to become the go-to local supplier for European industrial giants like Infineon and Bosch. They're basically embedding themselves even deeper into the very fabric of the European supply chain.
You know, when we think about what holds our digital world together, we usually think of code, right? But it's really advanced materials. And right now, there's one company quietly building the physical foundation for the next huge leap in technology. So let's take a closer look at Resonac and the future it's literally packaging for all of us. So the industry is making a massive pivot. The old way, what we call front-end innovation, was all about shrinking things on the chip. The new way, or back-end innovation, is about building chips upwards and outwards. We're talking about complex, multidimensional structures. And this brings us to the new frontier, advanced packaging. Now, I know, it might not sound glamorous, but believe me, this is where the real revolution in computing performance is happening right now. It's the key to finally moving beyond Moore's Law. So what is it exactly? Okay, think of it like this. Instead of building a sprawling single-story building, you build a high-tech skyscraper. Advanced packaging stacks chips vertically. But what's even crazier is its ability to stitch together smaller, specialized chips, called chiplets. Imagine them like high-tech Lego bricks, one for graphics, one for AI, one for memory, all snapped together into one custom-built, super powerful processor. This is the magic inside the most advanced AI GPUs But here's the catch. You can't build these chip skyscrapers without some incredibly special materials. We're talking about the glues, the insulators, and the protective layers that hold these 3D structures together under insane amounts of heat and pressure. These materials are the true unsung heroes of this whole revolution. And this is where our main character enters the story, a company that was purpose-built to dominate this new era of packaging. So let's meet Resonac. Resonac was officially formed in January 2023 from a merger of two Japanese chemical titans, Showa Denko and the former Hitachi Chemical. One was a master of upstream raw materials, the other specialized in downstream functional materials. You put them together, you get a vertically integrated powerhouse. And this wasn't some small deal. Right from day one, their combined semiconductor and electronic materials business was worth around 450 billion yen. That made them an instant global leader, with top market shares in all these critical packaging materials.
Okay, so having the right materials and massive scale is one thing. But how does a newly formed giant actually execute its vision? Well, Resonac's answer is a focused and frankly incredibly smart playbook for Europe.
Resonac strategically planted its European headquarters in Munich, Germany. Now why there? Because it puts them right in the heart of Europe's industrial and automotive engine. They're just a stone's throw away from huge customers like Infineon and the massive R&D centers for car giants like BMW and Audi. And that proximity,
It's central to their whole philosophy of co-creation. This isn't just some corporate buzzword. It's about embedding their engineers with their customers' engineers to solve fantastically complex problems together in real time, not just selling a product off a shelf.
So here's how that works in the real world. Resonac partners up directly with European chip makers and car companies. Together, they actually co-develop and qualify new materials, like the super advanced heat-resistant components needed for the power modules in next-gen electric vehicles. This whole approach just cuts out all the usual delays of working across continents, and it's massively speeding up innovation for a sector that's in the middle of a huge transformation.
To win in this new landscape, Resonac knows it needs to be laser-focused. And, that means making some tough, strategic calls about where to put all its energy and resources. And you don't have to guess what their plan is. Their CEO, Hideo Takahashi, has been crystal clear about it. They're aggressively pursuing strategic acquisitions. In a market this competitive, that's not just about getting bigger, it's a clear signal that they are all in. They want to outmaneuver their rivals and lock in their spot at the top.
And you can see this strategy in action right now. They are doubling down on everything related to semiconductor packaging and R&D hubs. At the same time, they're selling off non-core assets, like the planned sale of their F2 chemicals business in July 2025. This isn't just trimming the fat, it's sharpening the spear to dominate the future of chip packaging.
So all of this brings us to a really fascinating final thought. As microchips stop being flat circuits and start becoming these complex 3D cities, who holds the real power? Is it the architects designing the chips? Or is it the companies like Resonac, the ones providing the advanced materials, the very steel and concrete that make these incredible structures even possible? It's a question that's probably going to define the next era of technology.